Hi, everybody. It's great to be in Sydney. I'm Rob Richardson. Some people know me as Rob Rich. Rob_Rich on Twitter. It's great to be in Sydney. Here's the part where I say, I'm definitely going to post the slides on my blog tonight. You're going to email me in a week or two. I'm going to reply in a month or two. No, really, I'm going to post. You can go to my blog right now, robrich.org/presentations. And you can pop open the slide deck right now. We're going to learn ES6, the language and the tools. robrich.org is my blog. So that was fun. Well, maybe I won't be using this. So I do a few things in JavaScript and a few things in .NET. You're not going to trust what I have to say unless you know that I know what I'm talking about. So that's me. You can hire me to do this. So I'm from Arizona in the United States. There's me. Arizona is a great place. This isn't my picture, but I wish it was. I've seen skylines like that, though, and it is so beautiful. But you know, every paradise has a downside. Here's the weather in Phoenix. A little warm. So we're going to talk about ES6. Now, starting off terminology, ES6. Well, is it JavaScript? Is it JavaScript Harmony? What's the difference between ES6 and this EcmaScript 2015 thing? Well, in actuality, all of them are exactly the same thing. As we got going along, ES3, ES5, because programmers can't count, ES6, and we got to the tail end of ES6, and they said, well, we want to go on a faster cadence. We want to go on a yearly cadence. So instead of calling it ES6, we're going to call it ES 2015, and the industry kind of went, eh. So going forward, we'll have ES 2015, ES 2016, and we're going to call them ES6 and ES7 because, you know, naming conventions. Naming is hard. So ES6, that's what I'll call it today, but you can call it whatever you'd like. The ES6 story on the server is really interesting as well, but we're going to focus on the ES6 story inside the browser. You've probably been doing ES3 for a while. ES5 is getting pretty cool. And you open up ES6, and it's like, the term that comes to mind is visual Fred. Remember when we tried to go from VB to VB.NET and we had this big trauma? It's really not that hard, and so hopefully we can get over that move and get towards ES6. So I'm going to kind of break it into two major groups of things associated with ES6. There's the new features of the language, which is really elegant, and then there's also new syntax that makes existing jobs easier. Now, ultimately, we're going to want to latch onto this really hard, and this is going to be a theme that we keep coming back to. We're going to want to latch onto this and keep running with this and ES6 all the things, and that's not it. Ideally, you want to create these experiences to increase legibility of your code. So sprinkle in these features as it makes sense. But don't go overboard and try and ES6 all the things. Grab a few features as they start to make sense and implement that in your code, and you'll have a much more successful experience. So new features and new syntax, new ways of doing existing things. Under the hood, it falls back to the way we've always done it. We'll see that with classes in particular. So then the magic question, can I use it today? Yes, but. So I'm going to click through here to the EcmaScript 6 compatibility table. And it's really fun to kind of see, well, if I have this browser, how much of ES6 does it support? And we're getting pretty good, except for this one. And this one. And then we get into mobile browsers, and we start falling off again. So at this point, you're going to turn me off and say, yeah, no. Especially as we get into 2016 or into other features, we start seeing the support go down a whole lot. So how can I use it today? Well, let's create a mechanism where, let's imagine a reality where I write in ES6 and I compile to ES5. Well, we call it transpiling. Well, how is transpiling different than compiling? Some would argue compiling is the umbrella, like unit testing is the umbrella, and then there's little pieces under it. Some people argue that unit testing is one of those little pieces, and compiling is one of those pieces, and transpiling is a different piece. For our purposes, transpiling is just taking one language and moving it to another language that has a similar level of abstraction. When we compile, we go from C++ to C, or we go from C to assembly. We're going from ES6 to ES5. We're taking a sideways track. Is that compiling? Ask the TypeScript guys. Yeah? We're going to call it transpiling. We'll take code from ES6 and we'll turn it into ES5 code. And then now, because we have evergreen browsers, ES5 code does just fine. In time, we can take maybe some of those shims out and just start running our ES6 code more in the browser. But by then, will we have moved on to ES7? Let's create a mechanism where we can start leveraging the features that we want to today and transpiling them into the browsers that run today. So we can leverage the newest stuff, and our users can still use our sites, thus transpiling. So the interesting thing about this transpiling is it takes this tool chain. And so as we approach React or as we approach Angular, we start looking at the tooling associated with using it. And that's really unfortunate because we really like that hello world where you just open Notepad and you start typing and you open the browser. Yeah, that's not ES6 world today. But as we dig into the tools, you'll see that we can kind of break that into a really elegant experience once we've got those tools under our belt. So we'll look at kind of three groups of tools. We have the polyfills, we have transpilers, and we have bundlers. Transpilers we kind of dug into a little bit. Let's dig into it quite a bit more. But let's start with polyfills, because that's really fun. So polyfills, let's harken back to the modernizer days when we were looking at jQuery and those types of realms. And let's use the analogy. Can I put a polyfill in here? Well, what was really cool is Modernizer would shim in all those extra div tags, article and nav, and it just kind of made all those tags work, which was great. That was an effective polyfill. But could I polyfill canvas? Yeah, technically I could have rebuilt the app in Flash, and I could have also built it in Silverlight, and now I could kind of shim between them. But I would argue that's not a polyfill, that's a port. Yeah, let's get a few beers and we can argue that for a while. So can I polyfill? I would say if the level of effort is smallish, yeah. If we're able to achieve similar functionality without a whole lot of effort. And in the cases where that makes sense, polyfills are really easy. And at that point, let's polyfill those things into place. As those standards become possible in the browser, as the browsers implement those features, those polyfills can fall away. And now maybe we don't need that HTML5 shim.js. The next level is those transpilers. And there's two major transpilers that are in use today. There's others, but for the purpose of avoiding decision fatigue, Babel is kind of the kingpin here, and TypeScript is really interesting as well. TypeScript gives us some more benefits when we're coming from C# or Java, and we have that kind of classical language. We're going to focus on Babel today because it kind of takes the stance that that JavaScript, we're just going to take JavaScript at its core and just enable those additional features. So what's really cool about Babel, if you start off with Babel JS, just pop open the Babel JS website. It has a really neat REPL, a read eval print loop, where you can just start typing the ES6 code. And it will produce that similar code in ES5. And so I've got this experiment I want to do. I want to kind of dig into it. Well, I can just sit it here in the REPL, and I can play with it and get that experience. So for an on-ramp, I don't really want to open up the browser and type all of my code in there and then copy the thing into the other place. So we'll come into Babel's site, and we'll click on Setup. Here inside Setup, I can pick my tool of choice, and I can pull up the code that makes that happen. So I think this is particularly wonderful. Am I using Browserify? Here's the code to make it run in Browserify. All of the instructions start with npm install because Babel is a Node tool. So yeah, you need Node on your box. But I can dig into, am I using it with Jasmine or Karma or .NET or Jade? All of those things then have these shims to be able to leverage Babel in really interesting ways. Babel will take our ES6 code and turn it into compatible ES5 code. So we dug into the REPL. That was pretty fun. Any questions on Babel before we go too far? So the really cool part about Babel is that it shims in all of these ES6 features by replacing them with ES5 features. There's some things that we can't do that with. One of the most notable ones is imports and exports. The module system. The module system depends on loading other files. And ES5 can't just say, well, go load the other file. So we're going to misuse bundlers for that purpose. We're going to misuse a bundler to say, go crawl my dependency tree, find all the dependencies, package them into one piece, and now I have one file, and so the dependencies are already resolved. In effect, we can think of this as turning ES6 code into AMD, turning CommonJS into AMD. So Browserify was the first one that accomplished this, and Browserify gained market share really quickly. Browserify has kind of fallen out of favor, and Webpack is the one that's taking over. Webpack is immensely powerful and offers us a whole lot more options towards transpiling our ES6 code and bundling things. And so what I'm finding is that Angular is moving to Webpack. React suggests Webpack. Aurelia is moving to Webpack. And so I would argue that Webpack won this war. So Webpack is really interesting. Just from the command line, if I just say npm install -g Webpack to get Webpack installed globally, and then I just say Webpack, my source file, my destination file, it will do that transpilation. So in this case, we said, let's transpile main.js into bundle.js. It'll go look through main, it'll crawl through all of its dependencies, and it will produce this final bundle. Well, that's interesting, but that's not transpiling our ES6 code. But let's dig in a little further. Just running Webpack with a big, long command line isn't as much fun, so let's create a webpack.config.js. And webpack.configs get immensely large. We're not going to get too big there, but here's kind of a hello world Webpack config. We have this entry, this starting place, that first file in the command line, and we have an output file name, that second one we had on the command line. This is kind of that hello world Webpack where we say, I want to start here and I want to end there. So with Webpack, we've got that mechanism to get our bundles into one file. Any questions on Webpack before we dig in too far? So we want to take Webpack and we want to take Babel and we want to mush them together. We want to say, hey, Webpack, as you're wandering through your dependencies, run each file through Babel and get the ES6 to ES5 transpiling goodness. So I added another section to my webpack.config, this module section, and it says, hey, every time you hit that's a regular expression that ends in .js. Every time you hit a .js file, go run it through Babel. There's a few more things that I have in place here. I have a Babel RC file, so let's zoom into that Babel RC file. And I have this presets. Well, Babel is really interesting. It's this very pluggable architecture where I can say, well, what rules would I like to transpile? In this case, I said, well, everything in the 2015 spec. There's various plugins into Babel. Let's come back to that one. Then I run a whole bunch of npm installs, and now I run Webpack, and I've got that transpilation process. For each JavaScript file, it's going to go wander through the dependencies. Each dependency will get transpiled from ES6 into ES5. I'll end up with a single file when I'm done, and I reference that single bundle.js file from my HTML code. So we talked about presets. Let's dig into that a little bit farther. Each of these presets enables a rule set, basically a group of rules, and Babel has quite a few of them. ES 2015 is kind of the one that we like to focus on to get from ES5 to ES6. We can enable other features, ES7 features with the 2016 preset. We can pull in React presets if we'd like. And then there's this group of stage presets that are kind of fun. We can say, well, for the various levels of development of these new draft JavaScript features, I want to pull in that. So if I pull in stage 4, it's pretty much everything is done with that. Browsers may start supporting that. I want to pull in that rule in my transpilation as well. Stage 3 is more of a incomplete spec, or a complete spec, but browsers haven't done it. Stage 2 is kind of a draft all the way down to stage 0, which is like, hey, I have an idea. Let's try this. So I can turn on whatever levels of things that I'd like just by including these additional presets. Back in this Babel RC file here in this array, I can just grab those presets. So I may include ES 2015, ES 2016. Maybe I'm including some React things to get my JSX to compile. Or I'll go full hog and I'll say stage 0. I want to transpile everything. I want async and await in JavaScript. I want to pull in all the things. So I've got these stages here in my Babel RC. I've got this Webpack that describes running Babel for each of my JavaScript files, and then Webpack to do that module loading. And now I've got that complete system. Now I could walk through 1,000 different other things associated with Webpack. I'll leave that to you. Webpack files do get this big. So ultimately, answering our question from the beginning, can I use it today? Yes. Let's use Webpack. Let's use Babel to be able to write ES6 and run ES5 in the browser today. So now that we've answered that question of saying, can I do it? Well, what can I do? What is this ES6 you speak of? Any questions on tools before we dig in? Yep.
As long as the transpiling is concerned, so why should I use Babel JS over TypeScript? Because TypeScript gives me more outside, annotators and compiling writing and all these things, whereas Babel is anything.
That's a good question. Why would I use Babel over TypeScript? Why wouldn't I just go full hog and go to TypeScript? Ultimately, that's a choice. Babel keeps more towards the JavaScript standards, towards EcmaScript, where TypeScript kind of adds extra things. And so if you want those extra things, TypeScript is definitely where you want to go. If you don't want those extra things, Babel is where you want to go. If you want to look at more of those stage 0, stage 1 things, TypeScript doesn't have those and doesn't have a way to plug them in. So Babel is kind of a better fit there because I can dig into more of those advanced features. If those advanced features aren't important and typing is more important, TypeScript is definitely a better choice. Great question. Yep. Do the tools generate a source map? Webpack has a plugin for that, and you just say, hey, I specify my dev tool, and my dev tool is the type of source map that I want to produce. And yes, the source map spits out. The really elegant thing about the source map then is I reference my bundle.js. It has that source map decoration at the bottom of the file. I open up the F12 developer tools, and I am debugging my ES6 code, but my browser is running the ES5 code. And that is such a magical thing. Yes, source maps are wonderful. Any other questions? So we've got this build process. We're now able to take advantage of these things. And we're going to skim along the top of these features. This is hardly an exhaustive list. But let's look at some of our favorite features. Here's my warning again. Use these things sparingly, because it would be just as easy to sprinkle ES6 over everything, and now my code is completely illegible. Let's avoid that. Use it where it makes sense. Use it where your code is more terse, more descriptive. The moment you get clever is the moment you get scary. I love this quote. My friend Jeremy Clark, code like the person maintaining your code is a homicidal maniac that knows where you live. Typically, the guy coming behind you that has no idea what you wrote because you wrote it 2 weeks ago is probably you. So code for legibility. So variable scoping. One of the things that we love and hate about JavaScript is that curly braces don't define scope. Curly braces define curly braces. In ES5, we have mechanisms where we can get into this really interesting place where this variable exists both above and below where it was defined. Is JavaScript broken? Some might argue this is perfect. But in ES6, we have new mechanisms for accomplishing this. We have let and const. Let and const will both pay attention to the scope of the variables, the curly brace scope, and will behave as you expect. So for example, we define let message here in the middle, and if I try to use that message variable above or below that, I'll get an exception, as I expect. There's mechanisms of dead zone where we can get into some interesting places, and ultimately Ben Scott Allen's ear as we get into these dragony places. But then the next question is, so do I use let or const? We're transpiling, so ultimately, in spite of the fact that we may define it as immutable, it's not immutable. Harkening back to our C and C++ days, it's a constant pointer. If I point to an object, that object is not immutable, and so I could still start manipulating, adding properties, removing, changing data in that object. But that pointer is immutable to that object. So ultimately, const is more a communication to our fellow developers that we don't expect this to change, rather than a hint to our compiler to unbreak this. So I say use const when you don't expect it to change. Use let when it's data that will change. And that communication mechanism may be more important than what the name difference actually does. Ultimately, discuss that with your team, find a convention that you like, and run with that. Let and const, though, give us that ability to work through curly brace scope and find interesting places there. So fat arrows, this is our quintessential thing that we're so glad that we don't have to type function. Fat arrows. Fat arrows are wonderful because it reduces that function word down to a smaller piece, but it has some side effects. It binds this at the point where you define it, which means you can't later bind this using like the apply keyword or the bind keyword. It's already bound. It's always an anonymous function, and it has an implicit last line return if it's a single function, single line. That can be wonderful, or we learned this in the CoffeeScript days, it can lead to really unexpected results. So function is not deprecated by any means. For that heavy lifting where you really want control over this or you want kind of a longer experience, function is definitely the right keyword. Ultimately, decide together with your team which one you like and pick the style that works best for you. So on the left, here's our ES5 function. We had to type so many characters. We had this 3-line just to say, hey, I want to double this number. On the right, we have this arrow function where we just say, hey, you know, go grab that input variable and turn it into a doubled result. Well, that's a little bit magic, so let's break that down a little bit. I start off with my regular function. I'm going to turn it into a fat arrow function. I notice that I only have a single parameter. That means that the parentheses are optional. If I had 0 or 2 or more parameters, I couldn't do this. So let's pull the parentheses off the front. I also notice that it's a single line and that I like that it's an implicit return, single line return, so I'll shorten that, and I got to that result. So now setting that into place, I could say array.map, that really short function, a such that a dot times 2, and that makes my code more legible. The intent flows through more so than the big word that has lots of letters in it. What's really interesting about this, each of these 4 are valid. They're valid JavaScript lines in ES6. So one is not more better than the other. And there are places when each of these is the most descriptive thing to use. So ultimately, get with your team, find the style that you like the best, and leverage that. Fat arrow functions can be really powerful in making your code more concise. But if you just go find and replace the function keyword with arrows, you'll probably find unexpected results. Classes. Classes are one of these wonderful but horrid things that JavaScript has done to us because it makes it feel more like our classical languages, Java and C#, but it still is a prototypal inheritance under the covers. So use them sparingly, but of course, nobody listened to me, so Angular and React and Aurelia all use classes as their base construct, and they have these dependency trees and hierarchies. I would argue that if you're inheriting from something in JavaScript classes, you're on the border of doing it wrong. If you have a deep hierarchy, yeah, you're definitely doing it wrong. So under the hood, it's still this prototypal inheritance. So here on the left, here's that prototype where I created the constructor function. How am I implying that it's a constructor? Douglas Crockford said so. Yep, it's a capital letter. And then I have this dot prototype where I'm defining things that, is that a class? Yeah. But here on the right, it's much clearer. It's much more concise. I've defined a class, and I have a constructor called Constructor. I have methods that don't have the function keyword. They just have the name, and they're able to do what they expect. Ultimately, this and this work exactly the same. Which is better? I think this one's easier to read, knowing that it works exactly the same as that one. But because they work exactly the same, they're also interoperable, which is really fun. So we see promise is a polyfill. Babel doesn't enable promises. Promises can be really, really powerful. We're in this callback realm and we want to move to this promise realm, or we're starting to play with promises and we want to move to async. Promises give us the ability to kind of hold on to a result and sequence events in a much easier way than we had before. So here's a callback pattern, and it's not broken, it's just a little weird. Why is the first result always blank? Because it hasn't errored, so should I just ignore it? No. Here in the promise mechanism, I create a new promise. The promise takes in a function that has two parameters, the success and the fail. And then whether I succeed or fail, I call that result. And then later on in my code, I can say .then. I chain these .then functions, and I can just walk through my series of events with .then. The cool part about this .catch will catch all of the things, even if it errored in my .then callback. I didn't get that with callbacks. And callbacks, as soon as I handled the error right here, that was the end of my error handling. If this code failed, I was done. Here, this code could succeed or fail, and I would still fall into my catch. Here I called it the success and fail functions. Typically, we call them, I lost it, resolve and reject. And so you'll probably see that, that methodology. So this is one of those things that you need to polyfill. Polyfilling a promise isn't that hard because you can kind of create a mechanism to call a .then. Ultimately, there's like promisify that could take a callback and turn it into a promise. Promises are in browsers for the most part now. So maybe it's not necessary to polyfill promises anymore. This is one of the only ones that you kind of have to look at in another way. So all along, I'm not sure if you caught it, we have up at the top the thing that makes it happen. Thus far, it's been Babel that has empowered all of these things. Promises had a polyfill that enabled it. And now, modules. Babel's purpose is to transpile ES6 and ES5. Modules is about consuming other things. And so this is where we jump into that bundler to try and do that navigation between files. So here's that Webpack logo. We'll grab our Webpack config, and we're really glad that we can do this. In effect, we're taking common JS style code and turning it into AMD code. In common JS, we presume that modules resolve synchronously. And in EcmaScript 6, we also assume modules resolve synchronously. So kind of turning it into AMD, where it could be asynchronous, is a misnomer. Really, it's that kind of AMD style syntax that's pretty cool. We didn't have this in ES5 at all. So now we have this kind of ES6 export and import syntax. But we did have it in Node. So let's compare Node's mechanisms to ES6's mechanisms. In Node, if we have this square function, we'll have then this module.exports object. And this module.exports object then has various keys representing the things that we want to export. As I want to pull it in, I say require that library, and then I can call the functions that I've exported. In ES6, it's not all that different. I just put the export keyword right as I'm defining each thing. Yeah, technically, I could create an exports-like result object, but that gets a little weird. So here I've said export the square function, and then I'm going to import that in. I'm going to say import star as star, pull in all of the things. As lib, I'm going to rename it to lib in the same way that I called my local variable in Node lib. And I'm just going to call lib.square to be able to leverage that library. So the interesting thing is I can import it using a couple of different ways, and I can export it in a couple of different ways. I'm going to call out default because it's one of those ones that's a little weird. Export default function. Now, ideally, when I want to import it, I just want to say import the thing. And so export default makes it trivial to import things. Here, when I'm importing it, I'm just saying import lib from that library. So I called it lib, but they called it square. Basically, what I said is go grab that thing marked as default. So export default. In node land, that would be roughly akin to saying module.exports default is this thing. And then as I require it, I say require.default. In effect, it creates a key in that module exports object named default. So how do I export a function instead of this object with keys and values? You don't. You create this default export that kind of mimics that instead. So how do I know whether I'm supposed to import the default thing or a set of keys and values? You open up the file and you go look. Or you leverage TypeScript, and TypeScript will tell you. So how you import it and how you export it becomes a matter of that contract between those two files. I like to use default exports when I'm going to only export one thing, or the main thing. And I like to use regular exports when I'm going to export a whole lot of named things. I want to export a square function and a by2 function and maybe an add or subtract function. If I have a service that exposes lots of business logic associated with my class, I'll export all of those things. But if my class only does one thing, I'll probably do an export default to get that thing pulled in. Modules are kind of weird. Any questions there? So we kicked around a lot of cool things. We're back in Babel land, and let's look at string templates. This is really fun. So we've really wanted to do large strings, multi-line strings for a while, and we've built up these things. Handlebars is great in defining the two curly braces, the mustaches, to build up these templates of things. But it always comes out turning really ugly. So here on the left, we've got this string, and then we plus equals, and my favorite part of this part, putting the carriage return at the end of the string, which I always forget, so now I end up with like lines and words mashed together. This is painful. It's painful to do that templating and to walk in and out of, am I doing the template or am I doing code? Here in ES6, I do a backtick, and I just start going, and that is my string literal. Here inside my string literal, there's no backtick at the end of this line. There's no backtick at the beginning of this line. Here's the end of my string right here. And then when I want to get into code mode, I do a $ curly brace, and now it's looking into the scoped variables to try and infer the data that I want to pull in. So for example, I have an A and a B variable here, and I would just want to add them together. $ open curly brace, A plus B close curly brace. I really wish it was 2 curly braces instead of $ curly brace, but that looks gorgeous. We have multi-line strings, we have templates, and I'm not doing any heavy lifting of trying to get the carriage returns to fit anymore. String literals. Next up, building objects. So ultimately, this building objects is syntactic sugar for making object construction easier. I've got a whole bunch of properties, and I want to build one object with all those things. Well, I end up, module.exports is a great example of this. Module.exports, curly brace, some name, colon, that name, some name, colon, that name. So that redundancy right there is really painful. Well, now we can just say the names. And JavaScript will notice that I have variables in scope that match these names and pull them in. Automatically, I've got this really elegant mechanism for object construction. I can also kind of filter that in with other variables as I'd like. So in this case, I wanted an extra z variable, and I just called it out. So x and y are the ones that are implicitly pulled out of scope, and z is specifically crafted to be that value. I'm constructing objects in this way. I could also dereference objects, destructuring objects as well. So as I'm destructuring objects, I have an object that has all the pieces, and I want to pull variables out of it as I'm destructuring. So instead of var x equals c.x and var y equals c.y, I'll say, hey, let, open curly brace, a whole bunch of variables, in this case x and y, equals c. And it will go dig into that c object, pulling out the properties into my variables. So now I have an x variable that is as I expect, and a y variable. Well, that's really weird syntax. When would I ever destructure like that? Why would I want to do that? Import. So I've exported a whole lot of things in this library, and I don't really care about all of those other things. I just want these little things. I want the square function and the double function and ignore all of the rest. So I'm going to import this library, and out of those things, I'm going to pick out square and double. And now I have variables in my scope called square and double, and I don't care what your library called them, and I don't care that it came from your library. I'm just going to do that. So a lot of the things that we see in Angular and React and Aurelia kind of leverage this type of import syntax. Import, open curly brace, define a bunch of variables, and now those variables came out of that exported library, and I'm using the variable, and I don't need to know which library they came out of anymore. Destructuring objects. Yep. Good call. If I'm pulling it in, I need to know what the name of it was out there. So I can't change the name in this way. I could say, in this case, square as circle, if I wanted to call the square function circle, and that would produce that renaming artifact. Great question. Any other questions? Yep. It's just a named variable. If I were to flip square and double, they would still represent the same things. And so it's not like the order it was exported is actually the order I need to import them. It's just pick these things out of that object. That was a great question. Yeah, they're not ordered. So now we get to order about should they be alphabetical? Yeah, take that one up with your team. Yep. If I don't have the variable, do I get an exception or a null? That's a good question. I don't know for sure. I believe that you get a null if you don't find the variable up in your scope. But the cool thing is it will start to crawl up into other closured scopes. So it may not be in your immediate scope. It may be, up a few levels. So, ultimately defining interesting variables may lead to really interesting results if you didn't define all the variables you're expecting. That's a great question. I want to go explore that now. Any more questions? Yep. good question. As I'm building my imports and exports, do I need to define them as AMD and CommonJS? Is that your question? Mm-hmm. Ah, good call. So I'm building a library, and I want different people to be able to import it. Some may be CommonJS, some may be ES6, some may be AMD. How do I pull that off? Is that right? We're still trying to figure that out. And that's the unfortunate part, is that we defined really well the import and export syntax, but we haven't made a good shim of how that relates to other things. So in the short term, probably what that means is I'll need to define a different version of my library for each version of the places where they want to pull it in. And that's really unfortunate. Ultimately, we'll hope that this syntax will win, but we're not sure yet. And so yeah, maybe I have one UMD version and one ES6 version, and that gets me close enough. Or maybe I produce 3. Yeah, that's painful. So we've got dereferencing objects, the REST parameters. I want to have a variable number of arguments to my function, and I'm left with this arguments array. And this arguments is not really an array, so I do these really interesting things like array.prototype.slice.call. I've forgotten what happens after here. I copied it out of the last thing, and if I typoed it, yes. I want the rest of the parameters. So I have the 3 dots, and I have this variable. I happen to call it the rest, but you can call it anything. And it becomes now an array of all the rest of the parameters called to my function. The interesting thing is this is a real array. So I don't need to do this, but shim it into an array. Also, because I wanted the first 2 parameters to be real parameters, I don't have to like pop them off the stack in my arguments array. I can just grab the rest, and I can start to leverage that as a real array. Rest parameters. We also have this spread operator. So if I have an array and I want to pass it in as a bunch of parameters, I can take my array and move it the other way. So previously, where I would do apply or call or something like that to try and get my array apart into pieces, I now just call the spread operator with these leading 3 dots, and I'm able to get to where I need to be. Now, the interesting thing is you can tell, the spread operator is kind of that more powerful array literal. So for example, here in ES5, when I'm trying to take that user input, the parts, and kind of put things before and after, do I need to unshift first? Do I need to push first? Was it shift or was it unpush? Pop? Ultimately, I end up with this really awkward syntax that doesn't really convey what I'm trying to do. Here on the right, I've got that parts thing, and I build my lyrics array, and I say, hey, I want to put some stuff before it, 3 dots, and take your array apart and put it in place, and then I'm going to put some stuff after it. And I've got that exact same thing, but now I'm conveying that intent much more easily. So we've got rest, and we've got spread. And you can tell them apart because the rest parameter has those leading 3 dots, and the spread operator has those leading 3 dots. Oops. Can you move one of the dots to the end, maybe, to kind of do? Nope, they are exactly the same syntax. So how do I tell the rest operator from the spread operator? Well, the rest operator is always a parameter into a function. And the spread operator is always the other parts. So if I have a function declaration, even like an array literal fat arrow function, and I see the dots in there, then that's the rest parameter. It's breaking it apart. And otherwise, I have that, or the rest parameter is putting them together. Otherwise, I have that spread operator that's breaking them apart. Yeah, I really wish they had used a different, I don't know, plus dots at the end, but rest and spread can be interesting. So ultimately, we took this really quick tour through this ES6 syntax. I'm going to say it again. Use these things sparingly. Use this where it makes your code more legible. Don't ES6 all the things, but ES6. This is now approachable. You can use this today. We work our way through Babel and also Webpack to get from ES6 into places where our browsers can use them today. And so ultimately, yes, you can use ES6 today. You can use it with your existing stuff. And that's what I've got. Any questions? Thanks for coming. Yep. Mm-hmm. Mm-hmm. Right. Good question. Is there a mechanism in ES6 to deep copy? There really isn't. I lean on two different tools. One is serialize it to JSON and back. Ow. Or I lean on Lodash to be able to pull that off. Great question. Thanks for coming. My Twitter is Rob_Rich, and give me green things. We like those.